Are we running? Uh, okay, I think people are starting to join in right now. Just, could you guys just type in the chat and let me know if you can hear me? And if the chat works. Yeah, it's good. Okay, cool. Yeah, people are starting to join in. I think we'll wait a couple more minutes before we get started on the actual presentation, but for the time being, we'll get started with some introductions. I think we'll just give it a couple minutes to get started. Um, yeah, we're getting started in a couple minutes. We just wanted to let some people roll in, but um, we're just gonna get started in a few. Um, for the question about why it's not on Zoom, we recently switched to YouTube because we think it should be more accessible. So hopefully we can get a couple more people to join in, and then we'll really get started. I think we'll properly get started at 6:10. Um, okay, I think we're just gonna hop into it and then hopefully some more people start to join in as we start. Um, Hello everyone, I'm Neil and I'm joined today by Vikram and Arav. Today we're going to be talking about drivetrains and game strategy and Weird Don't Blink. This is First Tech Challenge Rookie Rescue, and let's hop right into it. So the first thing we're going to talk about is what a drivetrain actually is. A drivetrain is basically all of the motors and parts that are powering your wheels. It is the structure of your robot, and it is what you build everything on top of. So the first layer of any robot is your drivetrain. Then comes um, your manipulators or any of your end effectors, and then that's kind of how any robot is basically built. Arav, do you want to take drivetrain design?
Yeah.
And
So when you're first deciding your strategy after kickoff, you want to design your drivetrain. So some things to factor in is the cost and the speed, the power, the maneuverability, the offense, or if you're going to play offense or defense, and if you need any traction. This year's game, you don't need any traction, but previous year's games, if there's any objects on the field that where you need to climb over, you're going to need traction for that. You're also going to want to designate a specific amount of motors for your drivetrain and the shape of your drivetrain. If you want an H square or a H or a square, or if you want a triangle or a rectangle, you have to decide that before you build your robot, so you can design your robot around that.
all right, so Vikram, do you want to take drivetrain design?
Yeah. So there's a lot of things to keep in mind when designing your drivetrain. So one of the biggest things would be cost. So this is like what kind of material you might be building your drivetrain out of or how you're actually designing it. So a simple straight-for chassis might be a little bit less costly than like custom manufacturing a parallel plate design or making your own design because it comes with the parts and it's already based off of the go build a system. Another thing is like your materials available. So if you have like wood, aluminum, those are different things you can use and like build into your structure to maybe make it better than a simple straight for chassis. And then tools needed for fabrication. This could be like a CNC mill, um, a 3D printer, or some drills maybe to cut wood, something like that. So the time needed to build. So this is really important, especially for teams that may have less experience. So like a straight for chassis could be really easy to build because it comes with a kit, it comes with instructions for you to build it. But something else might take a little bit more time and more tinkering to actually get it to work. So that's something important to keep in mind. Minimal maintenance is also something you want to prioritize. This is something that really changes based on the drivetrain design. And so here on like the right, we have an image of a straight-for chassis design with like one of the older Go Builder models. And so you can see that it could be a little bit difficult to like change things out because there's not much room here to like access the different motor screws and the miter gear set screws. Those are different things that could be a little bit difficult to access based on your drivetrain design. And then meeting the
So
requirements for the
yeah,
game is a pretty essential thing.
yeah. So when it comes to these motors, the main thing that gets to be really hard is building on top, right? Remember what I said at the beginning. A drivetrain is just the base of the robot, and all of your end effectors go on top of that. Now, if your motors inside of these U channels on the bottom are taking up so much space, it's hard to screw things in that would go on the top of the U channels, and it makes it for makes for like a lot more difficult design when it comes to attaching things and making your end effectors.
You also want to keep into factor your center of gravity. You always want a low center of
Yeah.
gravity so to make the hang easier and so you don't tip.
Yeah. Not every game has a hang, but it's good to have a center of gravity that is very central and low because oftentimes in games you'll be reaching up very high or reaching out a lot. So you want to make sure that your robot isn't tipping in one direction or the other. Now let's get into some types of drivetrains. So there is a mechanism drive, which is what we usually use and what we would suggest. A six-wheel drive, which is down here. This is a mechanism. And then there's lots of other different types of drivetrains. These aren't the only six that are around. There are many, many different types of drivetrains, and trust me, they all have their different advantages and disadvantages. But today we're going to be focusing on these main two because these are the ones that you guys will primarily be using throughout your FTC careers. But let's get into how a mechanism drive actually works. So, Vikram, do you want to explain this?
Yeah, so the way a mechanism drive works is you can think of like each wheel kind of based on based on the way their rollers face. You can think of that as a way that the mechanism roller can move. So it's a little bit weird, but you can see like one of the rollers, say like the top right corner, and the wheel that's there has a roller facing in like that 45-degree direction, but it's also facing like forward. So this kind of gives it like if you powered on that motor and every single motor is moving forward or two motors are moving forward because both of those because like the two cross motors have like a vector facing in that direction because you have one motion can face forward and the roller makes it go 45 degrees. It would move 45 degrees. It's kind of hard to explain just like
Yeah,
this,
I agree.
but
I kind of put Vikram on the spot, but
yeah,
in
it's
simple
like a little bit.
terms,
If you look at like Game Manual Zero, they have better diagrams to explain it, and it's a lot easier to understand based on.
yeah, but in simpler terms to understand based on this diagram, what we can see is all these rollers are angled, and if you draw an angle from this angle to this angle, and then this one to this one, if you draw a line from this one to this one and this one to this one, you'll find yourself drawing an X. And this X, or this orientation of the wheels, allows you to move in different directions based on which way you power certain ones. So, for example, in this top left picture, if you power this wheel straight and this wheel also straight, you can achieve diagonal motion, right? The great thing about a mechanism drive is that you're able to go forward, backward, and sideways. So, for example, if you're going to the left, you move this wheel backwards, this wheel backwards, and these two forward. And that gives you that sideways motion. And it's vice versa for the ones on the other side, and then it's simply all back and all forward for the ones going forward and backwards. Um, Now let's give you a quick mechanism wheel demo. These are actually the coolest videos of all time. This is a forklift. So this forklift has mechanism wheels, and it will showcase how it can actually move sideways. And it's kind of cool to see how something we're using in FTC is actually implemented in real life. So far, it's moving. Yeah, so you see, it's able to move sideways, and this is really great for maneuverability, right? Because let's say that he's going through a hall that he can only fit sideways. That gives him the ability to go through. And then here is another video of, I am not able to exit. Here's another video, let me just reload, of like one of the greatest teams of all time. But the goal of this game was to pick up these blocks and put them on this blue crate looking thing. But basically, you'll see how, sorry, I clicked out of the tab. But you'll see how a mechanism drivetrain gives you a couple things, right? It gives you maneuverability because you're able to rotate and move in many different directions. You have 0 degrees of turning radius, which means that if it's able to turn on its own axis, so usually, typically, you would drive straight and then curve to turn, right? A mechanism wheel allows you to turn in its place, which makes it so that you don't have to move as much when getting to different locations on the field, right? And what I would say is, or what I think what a lot of people would say is that mechanism wheels or mechanism drivetrains are a good choice for almost any game. I would suggest using mechanism drive for this game, even center stage, power play, and even freight frenzy. And the thing is that there are many different reasons to use one drivetrain over the other, but it all comes down to your team's strategy and what you guys value, right? So what Arav talked about in the beginning, is it that you value defense, so you want lots of traction, so you can push against the robots? Or is it that you want to be able to strafe left and right through different obstacles on the field, right? So a con of this is that it has low traction, right? It's bad at going over terrain. But many teams have found that you are able to still implement mechanism drivetrains with terrain games, and it all comes down to testing and seeing what you can implement and how you can implement it best. I think it's hard to program, but there's lots of resources on the internet. There's Game Manual Zero and definitely Rookie Rescue, which can help you out. I think there was actually a person asking about mechanism code today itself. And sometimes it can be inconsistent. And when I say that, I don't mean that in terms of its ability to go in each direction, but it sometimes doesn't give you the straightest path, and that sometimes comes down to lots of factors like your COG, like your center of gravity, um, or maybe like the way that the wheels are angled, like maybe you didn't screw them on right. So it's just important to be careful when actually using these mechanisms and making sure that using them in the best way possible. Arav, do you want to hop into six-wheel drivetrains?
Yeah. The six-wheel drivetrains, there's a lot of pros and cons, but just for a few, one of the pros is that it has a low center of mass, as we talked about at the beginning. This year, the hand, if you a better hand has a low center of mass, and in general, you just want a low center of mass. Additionally, it has very good traction. So, as Dino talked about, if you want to play defense, the six-wheel drive is great because it allows you to have traction when you're pushing up against robots. Um, it also has good maneuverability. So like the turns are pretty nice. Some of the cons is that it's pretty heavy compared to the mechanism wheel. You have to have more wheels, which is obviously more mass. It's also harder to build, so that's why we recommend mechanism wheels or mechanism drivetrain for rookies. And then it also takes up more space. In the middle, typically a lot of teams will have um, part of your arm in the middle of your robot, but now you have that big wheel, which is taking up the space.
Yeah. So now let's hop into a little bit of game strategy. So every year there are different components of how the game works, and a lot of things that you want to think about are how 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 you're going to score your elements. What's the fastest way? Is it using the same outtake and intake arm, or is it separating the two and maybe using something to intake, transferring into your outtake, and then outtaking with something different, right? That type of concept gives you the ability to only drive back and forth between your scoring object and the scoring elements, rather than having to turn around and then deposit out of your intake, right? So, for example, during Freight Frenzy, if I can pull up the right in this game, what you had to do was drive, pick up a sphere or a cube, and then drive out, and then deposit onto one of the three levels on this Alliance shipping hub or Alliance specific shipping hub. So many teams, what they did was, or a lot, what many teams did was, is grab a piece, come out, turn around, and then deposit out the front again. But if you notice, than that's much slower than driving in, driving out, and then depositing out the back of the robot. Then that completely eliminates your turning, and you're already in the correct direction for your next cycle. Cycle being every time you pick up a game element and then deposit it. So there's lots of different things that go into game strategy. If Arav and Vikram want to elaborate on what they think comes into it.
Yeah, I mean, I think like other parts that really come into game strategy are just like how kind of like how you want to optimize your movements, like kind of like what Neil was saying with the turning, but that's also like really built into your game design, um, with the way you design your robot as well. So if you're wanting to like turn around, then you might choose like a different design that could only maybe work in one direction. But if you're trying to avoid having to turn 180 degrees, then you might want to make your arm be able to like pick up the freight, for example, from that station, and then like turn like 180 degrees back to be able to place on that shipping hub.
You
And
also
then yeah,
sorry. You also want to design your end effector based on what you decide your game strategy is. So as Vikram was saying, if you don't want to turn around, you design your end effector so that it intakes from one side and outtakes from another.
So
so
another
that's like
thing that,
really
yeah,
important this year as well, because it what's challenging about the way this year can is formatted is that they have the station for the human players where you have to drop, where you might have to give your sample to the human player so that way they can put the clip on. But when you take the clip, you have to give them the sample. The human player will put the clip onto the sample. Then you have to take the specimen from them and then put it back on to the bar, um, in the center of the submersible. So there's like a lot of turning around, and you might want to build your robot and pick a drivetrain that would really work, so you don't have to turn around as much and spend as much time really moving around. And this is also why like I think a lot of teams are planning on going more for just samples over the specimens. But if you do really want to try going for specimens, then you have to try to you want to avoid turning around so many times because that takes up a lot of time.
yeah. So you definitely want to make sure
Neil,
that,
you're muted.
oh, so you definitely want to make sure that like during the season you're like most optimally grabbing your specimens and grabbing your samples and then depositing them. So what lots of teams will do is add an angle to their vertical extension so that they can in total limit their drive time. You almost always want to limit your drive time because it allows you to get to different parts of the field a lot quicker. So that would be by adding little forms of extension, right? In center stage, we had 5 stages of linear slides extending outwards. This gave us the ability to intake from the stacks at one side of the field, and it allowed us to be so much quicker around the field. But during this game, first of all, there's that extension limit, right? You're only able to extend 42 inches outwards, but you also want to think, okay, maybe I'll want to apply some of that extension to my outtake. But is that really worth it? You're traveling a total of about 2.5 to 3 tiles when you're coming from the submersible to these buckets, right? So you want to make sure that you're only giving yourself as much outwards extension for your vertical extension as you actually need, because by the time that you get here, you might have to wait for your vertical extension to get all the way to the top, all the way to the top. You want to make it so that while you're driving, it's synchronous. Your outtake gets to the correct position and you're at the right position as soon as you get there. So I want to open the floor up to questions now, but if you guys have anything you want us to talk about, please let us know. But you guys should just start asking away. If I'm looking down, I'm looking at the chat. And Vikram and Arav, if you guys want to like keep building, you guys totally should.
Oh yeah. So also like something I wanted to add this year, or sorry, that I wanted to add on was that with there's like GoBuild has released new Mecanum wheels this year. So we talked about how they have like low traction, but especially this year with the new release of I forget what it's called, but they have like dots and they add a lot more traction than before. So it's better for speed and it's better for terrain as well. So it makes it like a significantly better option than it used to be. It's still on the lower end, but it does make it a little bit more comparable to the other types of drivetrains, like a six wheel, in terms of traction and speed.
To answer the question in chat, what's better, tank, Mecanum, or Swerve? Um, it really depends on the game. Uh, we always recommend Mecanum for rookie teams and every team in general, but tank is better, as we said, for traction. Um, and Swerve, it's its own thing. I don't know if Neil, you want to talk about it.
Yeah, so I think between Tank, Mechanim, and Swerve, I would agree with Arav. I'm almost 100% of the time recommending Mechanim, but it does heavily depend on the game and the aspects of it. Oh, you guys are echoing. Um, Vikram, could you mute? Okay. Um, in terms of Tank, Mechanim, and Swerve, I would probably never suggest that you run a tank drive. And if you want lots of traction, I would suggest running six wheel. Mechanim, you have that maneuverability, you're fast. I think it's always a good option. Swerve is the same thing as Mechanim, for those of you who don't know, but it allows you to, like, in terms of your movement ability, but Swerve is a lot faster because you're able to actually turn your wheels in the direction that you want to go rather than you strafing because your rollers allow you to based on different motors being rotated. So that's a little bit hard to understand, but a swerve drive actually allows you to rotate your wheels so that you can go in different directions. And I think swerve is really great, right? Has lots of advantages because it's very fast, but there's lots of maintenance issues that you'll have to deal with during the season. And if you're at a tournament, you definitely don't want to have to deal with your swerve breaking down and then like having to deal with all of that.
Yeah, I think another issue with Swerve, why I wouldn't recommend it to anyone, um, is because it takes a while to fully uh like make it perfect and make it so it's not like worse than a Mechanom. Um, like it takes and it also takes like much more CAD experience and skill. So yeah.
Yeah. One more question came. Would you recommend Mechanim wheels for this game? Yeah, 100% because you are how you have to maneuver around the field really quick, and Mechanim wheels give you that ability. Another drivetrain I see that could be useful in this game is six wheel drive. I think that six wheel drive, because it gives you more traction, you're a lot faster, but you want to make sure that you still are able to like accomplish turns and you're still like you want to think it completely through because obviously there's all those disadvantages with both of them. But um, I think Mechanim is definitely the pick from DB's side. Uh, are there any other questions that you guys have? I'd be happy to answer.
Um, the question is, do y'all think claw or active take intake for picking up samples from the submersible is better? In my opinion, I would say it really depends on your team's build experience and what you guys know. I think both could be perfected in a way where it would work proficiently. However, if you're more experienced with an active take rather than a, a claw pickup, I think obviously the active intake would work better.
Yeah, there's like a lot of ways to pick up the samples this year. Uh, and so, but if you test out and you do some prototyping, you can see that like it's really easy to get both an active intake and a claw intake to work really well. So it's really like also like in addition to just experience, it's up to you to really decide on what you want. But a simpler claw intake does work really well. And like the biggest thing to really like optimize cycle time would be your transfer and your outtaking rather than maybe your intaking.
We actually talk about this a lot in our last rookie rescue video. So make sure to check that out on our channel and in our Discord server if you're not already in it. Are there any other questions that you guys have? How would you go about designing a parallel plate drivetrain? Um, so a parallel plate drivetrain, I think we have a video that maybe we can post soon on a parallel plate drivetrain, but for those of you that don't know, it's basically like exactly how it sounds. It's just a drivetrain that you make out of a bunch of custom parallel plates. So you'll put two on this side and then two on this side, and then you can either have mechanism wheels or a six-wheel system. But I think for the best way to go about it is um, making a square, or I think hmm, this is a complicated question. I think it's one for the DMs, but I think designing a parallel plate drivetrain is just like you have to cut out where your motors are going to go. You have to have the holes for your wheels, have a couple holes for support on the corners of your drivetrain, and then holes for your sunken plate. You want what else do you have? That's pretty much all there is on in terms of drivetrain specifics. But when it comes to designing any robot, you want all your end effectors, which are going on top of your drivetrain. So, you want to make sure that you cat out all the other parts of your drivetrain as well. So you'll add a slide mechanism inside, or slide a construction slide mechanism inside of your sketch in Onshape or whatever uh, CAD CAD software you use.
I think the biggest point when you're designing a parallel plate drivetrain is you want to plan out where everything goes. Because
Yeah,
once you fabricate it, uh, like you have to drill through or you have to like do some weird stuff to make it work if something goes wrong. So you have to make sure you plan everything and it's like all good.
Yeah, so someone else asked about like what they think about if a 6,000 RPM robot would be a good idea. So I think that's definitely not a good idea. It's a little bit of a higher RPM, and if you have any weight on your robot, it might not be able to carry it very far or very well at all. So what we try to this is also another thing to think about when you're designing your drivetrain is the motor ratios that you want to use. So this is also like combines with game strategy. So something that we did in Power Play compared to like center stage or this year was we used a 19.2 to 1 ratio motor. So it has a lower RPM and more torque. And this was important because we knew that there would be a lot more defense in the game. There would be a lot more robot to robot contact compared to another game. So we wanted that more torque to kind of give us an advantage over other teams. But in center stage and in this year, uh, we didn't really see that same relationship and like need to have a higher torque. So we went for like a 13.7 to 1 motor ratio.
Um, Another thing that we didn't really talk about in the slideshow was like the motor ratios that you want to use on your drivetrain. As Vikram just said, in power play there was lots of robot to robot contact, lots of defense, which means robots are pushing against each other, and you don't want to get pushed, right? You want to go to where you're trying to go. So that's where you would use a higher torque, which is 19.2 to 1, or like, or out of the two motors that people generally use for um, drivetrains, it's 19.2 to 1 or a 312 RPM motor. And the other is a 13.7 to 1 ratio, which is a 435 RPM motor. And these are two motors that are sold at GoBuilda. This is a vendor that lots of different teams use, and we suggest that use it because it's very reliable and they offer lots of different COTS parts that you guys can use. But I would suggest if you're looking for speed, 13.7 to 1, and if you're looking for um, the ability to fight against defense, use 19.2 to 1. Is it feasible to run a drivetrain with the servo? Mm, so, there is actually something called an H drivetrain, and that's where you're running the four main wheels in your robot with um, motors, and you have a middle wheel that's rotating based on a continuous rotation servo. And that servo allows you to move holonomically, which is basically in the same manner as a strafer, you're able to move sideways, straight, forward, diagonally. But I would never suggest using this drivetrain. Just stick with Mechanim. It's the better choice. So, yeah.
The next question is, do you guys think it's worth going for the level 3 ascent this season? In my opinion, I think if you can, obviously you should, but it depends if you can get more cycles in the time that it would take you to get to level 3. So if it takes you the whole end game, 30 seconds to get to level 3, I would suggest just running level 2 and cycle more. If you guys have anything to add.
I think it really comes down to like how fast your hang mechanism is. So if you're able to hang within like 2 seconds, then yeah, 100% go for it. But if your hang is a little cooked or not really working, I would suggest going for something else or maybe kind of working that out in your strategy right like before you actually design your robot. So you want to find out, okay, can I mean this is what Arav said, right? Can I cycle as much points in that amount of time? Um, okay. I think. Oh wait, is the stream still running, guys? Is the stream still running? Is everything good? Could I get something in the chat if it's working? Okay, cool. It's working. It's working. All right. I think we're gonna end it off here. Um, Thank you all for joining, and I hope you guys took something from Drivetrains game strategy and FTC Rookie Rescue. We're Don't Blink, and we're signing off. Thank you.
Thank you for
Bye.
showing up.